The walkthrough was easy because the team members has a chance to experience the flying environment. Our team also collect various data, text pictures is hidden behind boxes or in front of the box, and doing sample collection. As we fly off, we can perceive the sand on the ground, which is our solid symbol, and obtain a land image. There was a white paper at the very back. As we try to get closer, I can barely see what is on the paper because the light source was too high. Next, we can observe the LED lights and detect the color of the light through the downward camera adjustment. We noticed a liquid mixed with dirt as we get closer. Collecting data has become more difficult for pilots as it's essential to balance the drones. As you can see in the video, the pilot had a hard time to balance the drone to measure the data. So we decided to land on the envelope to get an accurate information.
For our sample collector, but instead of a bag, we thought of going with a cylinder instead, which this is a 100 milliliter graduated cylinder that was cut with a Dremel to our just desired length. And it was we had chosen a cylinder because we wanted something more rigid so that we didn't have to constantly keep the lip open. So that's why we chose a graduated cylinder as the main body for collecting the sample. And then moving on, we had some problems with some weight, like weights. So like the weights were supposed to be hooked here at the end. This was actually soldered on, soldered on more as in we melted plastic here, and that basically fastened this little metal piece here, like a hook. And so we saw that we just got rid of the external weights and put in these 3 metal balls so that the whole cylinder would sink in instead of just part of it.
For our solid sample collection, as stated in our previous presentation, it consisted of a 3D printed auger, essentially glued to a 360-degree servo motor. The entire device weighed just under, I think, 55 grams. And the idea is that we would be able to drop it onto the sand, toggle the servo by sending a character over the wireless XB communicators.
Sensor for Module 1, the orientation sensor and the temperature sensor. Humidity and temperature sensor. Ultrasonic sensor, altitude, and pressure sensor are added to the second module.
The team focused on collecting the live data, so we are using XP as a communication between the sensor and the dashboard. The live data from the sensor suite will show directly on the dashboard during the fly-off. At the end of the flight, the CFE file created to store all the data.
Step one, after opening up the files that we were able to save through the XB over the air, we noticed that the data was going to require a great deal of cleaning. This is a great example of one of the files we got back, where these little black diamonds with the question marks, they're just literally, they're unreadable characters. They don't represent anything other than a problem. Especially when you're trying to read and learn from the information you've gathered. So learning how to do that was part of the process. Some of our data looked better, but again, plotting something like this when we're looking at, 1,000 or 2,000 data points, it's just something that would not have been efficient to clean thoroughly by hand. So in order to do that, we utilized Python, Matplot library, and pandas for data analysis and cleaning. This is just one of the little helper scripts that was created to kind of expedite that process and make sure that we were spending the least amount of time cleaning the data as possible. The fine-tuning happened in Terminal essentially with the same tool set, but kind of just looping through things to eliminate outliers and things that were kind of getting in the way of us reading our data. I think a really good example of how some of our data was unreadable would be like our distance sensor, which might come back looking something like this, which, really, it's really hard to pull a signal out of this and get something useful. So with the data we did have, as you can see in the Python script here, we had orientation X, Y, and Z, accelerometer X, Y, and Z, gyrometer X, Y, and Z, magnetometer X, Y, and Z, and a temperature sensor on our first suite. And then altitude, pressure, another temp sensor, humidity, and an ultrasonic sensor on our second suite. Of those, the most useful, we believe, was the temperature. It was the one that we were able to pair with the most logic, maybe is the best way to put it. Here, you can clearly see, ignoring some of this stuff from launch, you can clearly see 3 events where something heated up the sensor rapidly and it slowly decayed over time, which we hypothesized had to do with one of the envelopes it was touching, and we were able to verify by cross-referencing the timestamps on the video with the timestamps on the data here. Once we were able to kind of lock in our understanding of, hey, this time on the video is synchronized with this time on the chart, and these 3 or 4 charts represent data that was taken over the same time series, we cleaned further the data and really tried to compare to see if we could pull any other insights that might be of some assistance in analyzing the course for use with our map. Unfortunately, aside from the fact that clearly there was a change here in humidity, we were unable to come up with a good theory or hypothesis for exactly why the reading did what it did. This is clearly not just an anomalous spike or an outlier or something. It's clearly something happened. But other than guessing at, hey, at this part of the flight, the ambient atmosphere was just slightly different. I mean, if you even look at the range on the humidity, it's less than 1%. So that sensor didn't help us as much as we were hoping. Same with altitude. It was really nice to have the altitude sensor. But, next to the video with the timestamps, other than being able to verify that the altitude sensor worked at least proportionally with the height of the drone in flight, it's definitely wasn't able to we weren't able to learn anything from the altitude sensor graph that we weren't able to see in the drone video flying. But it was still really interesting to look at. So the other thing that was interesting that we noticed is both pressure and altitude were definitely very clearly correlated, to the point where we were very skeptical that we didn't make a mistake in the sensor data we were collecting, but we were able to verify that these are in fact 2 different sensors sensing 2 different things that must just be very closely related. So that was interesting. And again, the altitude here within the area expected for the sensor, a difference of about 3.5 meters is well within the tolerance for the error expected. But it is fascinating that even with that, comparing it to the pressure sensor, I don't know. I just think it's really neat that they were so similar, I guess. Here's just an example of, I guess, the same temperature data that you see over here. One of our strategies to try to isolate times was to filter out thresholds. So like, for example, here, we would have pulled everything that was over 70.3 degrees Fahrenheit and plotted that. And then look, here's a spike. We were able to look then at that data frame or time series object, see the 0 values here and know that at this time, we could then cross-reference that with the video and see just what was going on. And so that's what we did. It was kind of a painstaking process. But again, we matched up the time on the video with the actual time. One of the things that was really helpful that we did with both of our sensor suites, that looking at the data for me personally is like one of the really fun parts. I loved the problem solving. We all love the problem solving, the engineering all the way through. There's something really fun to me once you have your first CSV file and loading it into a data frame and manipulating it and kind of sanding it and fine tuning it and prepping it for and getting it ready to be in a form where it tells some story of, or you extract some signal that can be useful. It's fun. It feels almost like a little mini Rubik's Cube, My expectations for the information we would glean from these sensors was that we would be able to more easily pull more useful data. But when I kind of take a step back and look and think about the process it took to go from soldering our first LED to learning how to, send a character over the XBs or whatnot, that we were able to send this stuff in flight, synchronize it with our video, and learn something about an environment that we couldn't immediately see or touch or feel, and pull this back and look at it and have a tangible idea of something that happened, I think is really cool. And I'm really proud of our team and what we were able to accomplish with